Hello. Today we're going to talk about transformations of linear functions. Absolute value functions we'll talk about at another time. So let's take a look at some of the objectives for the lesson. We're going to talk about different transformations. First we'll talk about translations, we'll talk about reflections, and then we'll talk about stretches and shrinks. And then we're going to combine all these transformations into a graph and an equation for a line. All right, so let's talk about what we've learned in the previous chapter. So we had talked about a transformational form for a linear equation. We started with the idea of y is equal to mx plus b, and then we expanded that to incorporate the shift horizontally with h and vertically with k. And then also we morphed m as a slope to a to talk about stretches and shrinks as it relates to a line. With a line, all we're talking about is whether or not we're making it steeper or less steep, meaning we're moving it towards a y-axis or as a fraction value towards the x-axis. Now we're going to morph the equation once again, and we're going to add f into the mix for the formula for the transformed equation for a line. And we're just saying it's a function of x, and basically there's very little change other than including this letter f into the equation. So we learned from the first form in the previous chapter, and now we're rewriting this linear form in function form, linear equation in function form. And that's y is equal to a times f, the function of x minus h plus k. All right, so f of x is the function of x. Just to give you some background on what f of x is. F of x is the same as y. And so if we say y is equal to f of x, it's the same, and f of x is equal to x, then we can say that y is equal to x. And y is equal to x ends up being the linear form of the parent function, which we've already talked about in the previous lesson. All right, so let's talk about vertical and horizontal translations. And there's a subtle difference between the two. So let's make sure that we know what those are. Y is equal to f of x plus k is going to represent the vertical translation as a shift in the line k units up or down. If it's plus k, then we go up. If it's minus k, then we go down. So here's y is equal to f of x, some line. We'll say it's y is equal to x. And then if we add k units to that equation outside of the function, we're shifting the entire line up at every point by k units. So you can see here this distance that's traveled between the origin and the y-intercept is going to be k units, both up or down. So we end up with y is equal to f of x plus k, and y is equal to f of x minus k. All right, so that's a vertical translation. And it might look something like this. My parent function y is equal to x, and then y is equal to x plus 3. I have that function x, and then I'm adding 3 to it. And so I just want to remind you of a couple things that we talked about in the last lesson. I want to make sure you put the arrows at the tip ends of the line so that they are lines rather than segments. I want you to do your best to draw the line to the edge of the graph. I need for you to label the graph, so you're going to label these two lines, y is equal to x plus 3, y is equal to x. And then you want to label the increments for both x and y. Just one isn't enough. So this is plus 1 here, this is minus 1, and minus 1 on the x-axis respectively. But at least label one increment on the x-axis and one increment on the y-axis. All right, so writing a translation of a function vertically. So I have a function, we're going to let f of x be equal to 2x plus 3. And then I want to translate f of x 3 units up. I want to graph and then rewrite the equation. Or you can rewrite the equation and graph it. So I'm going to take f of x, and then I'm going to add 3 to f of x. So it becomes y is equal to f of x plus 3. And then I'm going to substitute for f of x, which is 2x plus 1. And end up with y is equal to 2x plus 1 plus 3. Which is the same as y is equal to 2x plus 4. And so you can see here the line y is equal to 2x plus 4, and then the original line f of x, y is equal to 2x plus 1. And you can see that I've shifted the line up by 3 units. All right, so now let's talk about horizontal translations. Now, when we shift horizontally, that value is going to be now included inside of the function itself. And then also when it's minus h, the value is going to be plus h, so we're shifting to the right. And when it's plus h, the value is going to be a minus h, so we're shifting to the left. So you can see here, f of x plus h means a shift to the left by h units, and then y is equal to f of x minus h, shift to the right by h units, respectively. All right, so horizontal shift, that h value is within the parentheses. And then let's go through an example. So I'm going to take that same example, f of x is equal to 2x plus 1, and I'll translate 3 units to the left, graph, and rewrite the equation. So I have y is equal to f of x minus h, and then I'm going to shift by 3 units to the left, so this becomes a plus 3, so I'm going to write y is equal to f of x plus 3, and then of course I have outside of the function of x here with x, I add plus 1 here, and then I distribute the 2 and combine like terms, and I end up with y is equal to 2x plus 7. So initial line here, f of x is equal to 2x plus 1, then the translated line 3 units to the left ends up being y is equal to 2x plus 7. All right, f of x is equal to 4x minus 9. All right, so these are some of the classwork problems that I'm going to show to you. And so I want to translate a function g. So this is going to be a translated function of f of x, whose graph is a translation of f, 5 units up, and then I'm going to graph and rewrite the equation, that's a. And then I'm going to translate the function h, whose graph is a translation of f, 1 unit to the right. Then I'm going to graph and rewrite the function. So similar performance that we did in the prior 2 examples, 1 vertical and 1 horizontal. All right, so here we go. All right, so I'm going to translate a function g whose graph is a translation of f, 5 units up. So I'm going to take f of x, I'm going to add 5 here. It's very important, at least initially, when you're creating these translations, that you start in this fashion and follow my path. And then as you get more proficient at these, that you can start skipping steps. But please don't skip steps, at least for now. So I have y is equal to f of x plus 5, and that's g. So g is equal to this function f of x plus 5. And then I'm going to rewrite f of x as 4x minus 9. 4x minus 9 plus 5 ends up being y is equal to 4x minus 4. All right, so we have the function y is equal to 4x minus 9. That's the initial f of x. And then g of x, the function g is going to be a translation 5 units down. Y is equal to 4x minus 4. All right, so let's take care of the next problem. All right, so I have the same function f of x, and now I want to translate it 1 unit to the right. So I write my function g of x is equal to f of x minus h, where I'm shifting f by 1 unit to the right. So I'm going to rewrite this as y is equal to 4 times x minus 1 minus 9. I'm going to distribute the 4, combine like terms, and end up with y is equal to 4x minus 13. So I have my original function, y is equal to 4x minus 9. And then I have my next function, y is equal to 4x minus 13, shifted 1 unit to the right. All right, so here the two are that are graphed. All right, so classwork 1.2.1. So this is going to be, the work that we just did was work that you did on your own. You could have followed along with me. I'm not going to ask you to turn it in. However, now this classwork 1.2.1, and for all classwork, you're going to have to do the work. You're going to submit the work to me, either as an upload or showing it to me directly. Again, I will instruct you to do that outside of this video. So your first classwork problem, 1.2.1, which should be properly labeled. You're going to do the same thing that we just did. You're going to take f of x as 3x minus 2. You're going to translate it 4 units down. That's a. And then you're going to translate it 2 units to the left. That's b, graph. And then rewrite the equation of the function. I'm going to give you a moment to write this all down. You can also pause this video, and then I am going to move on. Okay, so let's move on. We're going to talk about writing reflections of functions across the x-axis and y-axis. So reflection over the x-axis. All right, so I'm going to say that a reflection of f of x is going to be y is equal to negative f of x. So that negative sign, and that the placement of the negative sign is important. Y is equal to negative f of x. So each f of x is equal to negative f of x. And now we're going to let f of x equal x plus 4, and then we're going to write our graph G as a reflection over the x-axis. All right, so I have y is equal to negative f of x, and then I am going to rewrite the function y is equal to f of x. That's equal to x plus 4. G of x is equal to negative f of x. So that's negative, and then in parentheses, because it's the entire value of the function, negative x plus 4, which ends up making g of x negative x minus 4. All right, and then I'm going to graph, and it ends up being a reflection here. You see in red, g of x is equal to negative x minus 4, where g is a reflection of f over the x-axis. All right. Okay, so let's move on. Let's talk about reflections over the y-axis. Actually, we're going to do one more example. All right, so I'm going to take 2x plus 1. Now I'm going to reflect it over the x-axis again. I'm going to write an equation. So this is another example. You can follow along here if you want to pause and do it on your own, just to make sure you understand what's going on. But I'm going to show you the answer. All right, so I'm going to take f of x, and for g of x, I'm going to make that a reflection over the x-axis, so I'm going to make it negative f of x. So g of x is equal to negative f of x. So g of x is equal to negative 2x plus 1, or y is equal to negative 2x minus 1, which I'm going to graph. So first I have my first function, and this really should be drawn to this blue line here. F of x is equal to 2x plus 1, and then g of x is equal to negative 2x minus 1. Reflection over the y-axis is this black line. Okay, now let's talk about reflections over the y-axis. Y is equal to f of negative x. So each f of x now becomes f of negative x. And we'll let g be a reflection of f of x over the y-axis. So I'm going to take y is equal to f of x plus 4. Here's the example. And then I'm going to make g of x by now only changing the sign of x, right? So f of negative x is different from negative f of x. Negative f of x, I change the sign for every term in the function. And now with f of negative x, I'm just changing the sign of the values associated with x, or the terms that include x. And so this becomes y is equal to negative x plus 4. So I'm changing the sign of x only. And I end up with a reflection. Okay. All right. So here we go with another example, then we'll get into some classwork. I'm going to take the same equation, 2x plus 1. I'm going to let g be a reflection of f of x over the y-axis. I'm going to graph and write g of x. All right, so you can work along with me if you want to pause. Now I'm just changing the sign of the terms that are associated with the values that include x. It becomes y is equal to negative 2x plus 1. So you see here is a line of reflection in y, f of x, the original equation, g of x, the reflected function. All right, so this brings us to, just to highlight some of the differences, negative f of x equal to y is equal to negative x minus 4, and f of negative x is y is equal to negative x plus 4. All right, so we're going to pause here for a moment. I'm going to give you another example in the next video, and then we'll come back and have some classwork problems for you.